Hello guys, welcome to Differentiation 101. So let's get started. See, differentiation is chapter 2 in Form 5. So this is your first introduction to the field of calculus. You do learn a few other chapters regarding calculus, right? So the chapter differentiation is very important because you will reuse this information in a lot of places, right? So what will happen is generically the symbols x and y will be used as the variables, but they can also use other symbols depending on the situation, right? So you will be given y as a function in terms of x, right? What you have to do is you have to differentiate, right? You have to differentiate, right? See, when you differentiate, first of all, the symbol y changes to dy dx. I mean, that is to prove that the differentiation is already done. And whatever in terms of x will also go through some changes. So fx will not be fx anymore. It will be f prime x, right? So remember, when you differentiate y, it becomes dy dx. So what happens to an equation when you differentiate it, right? In a ideal situation, you would want the equation to be in this form: y equals to ax to the power of n, right? And when you differentiate this, y changes to dy dx, and the ax to the power of n. What happens to that? A will still be there. You bring the n in front, so it becomes a times n. X will be still there, but the index of x you have to minus 1. So this is what happens every time you do differentiation. You bring the power in front and then you minus it by 1. See, for example, number 1, if you have, let's say, y equals to 3x to the power of 4. When you differentiate that, what happens? You see, this is in a form where you can differentiate it already. This is like the easiest question, right? So dy dx will become 3. 4 you bring in front, so 3 times 4, x to the power of 4 minus 1. So what you get is dy dx equals to 12x to the power of 3. That's all. See, it may seem weird why 3x to the power of 4 is becoming 12x to the power of 3, but once we look at the application, right, you probably will understand what is all this, right? For now, we just look at how to do differentiation. That's all, right? And one of the key mistakes, right, people do is that they do not know when to put the dy dx, the symbol dy dx, right? See, the moment this weird thing happens where you bring the power in front already and minus 1 already, then the subject of the formula should not be y anymore. It should be dy dx, right? So for example, number 2, let's say number 2, we have y equals to 3x to the power of 2. Then dy dx will be dy dx will be 3, 2 brought to the front, x to the power of 2 minus 1. So you get dy dx equals to 6x to the power of 1, but you don't have to write if the power is 1. So dy dx will be 6x. And also, you don't have to do this working, you don't have to show this working once you got a little better at this, right? Which means that from y equals to 3x to the power of 2, you can straight away answer dy dx equals to 6x. There's no issues about that, right? But if you think that you have to do working, you want to do it slowly, carefully, then you can go through all these, no problems, right? Number 3, let's say we have something like y equals to 2x to the power of 3 to the power of 2. Now, is this in a form where we can differentiate it already? No, right? Because it doesn't look like this, right? So sometimes we have to do some prepping before we can actually differentiate things, right? For example, like this question, right? What we have to do is we have to square the whole thing, right? And when we square the whole thing, see, we haven't done the differentiation. So the subject will still be y, and yeah, it will become 4x to the power of 6. Right, now you can differentiate that, right? And now when you differentiate, the subject becomes dy dx equals to, right, 4 times 6x to the power of 6 minus 1. Therefore dy dx will be 24 x to the power of 5. Yep. So how about when you have something like, let's say, number 4. If you have something like y equals to 5 over 4 x to the power of 6. So dy dx will be 5 over 4 times 6 x to the power of 6 minus 1. So you get dy dx equals to, you can calculate that, you should get 15 over 2 x to the power of 5, and that will be dy dx, right? See, this is the basic differentiation, right? Let's look at more examples. Right, here we have number 5. Question says differentiate the following, right? So when you have a very simple equation, y equals to 6x, how do you differentiate that? Y equals to 6x. Y equals to 6x, it basically means that y equals to 6x to the power of 1. Right, so when you do dy dx, it becomes 6. We bring the 1 in front as usual, x to the power of 1 minus 1. So you actually get 6x to the power of 0, and x to the power of 0 is 1. So this is 6 times 1. Therefore, we get dy dx equals to 6. So you see, guys, when you have y equals to 6x, dy dx is just that 6, right? If it is 6x to the power of 1. So next time, you don't have to do all this working, right? You can straight away answer. For example, y equals to 8x. You can straight away answer dy dx equals to 8, right? If y equals to negative 3x, you can answer dy dx equals to negative 3. If y equals to 2 over 3x, then dy dx equals to 2 over 3. No need to show working. This is not required, right? So this one, if you have y equals to negative x over 4, it's actually y equals to negative 1 over 4x. Therefore, dy dx equals to negative 1 over 4. So, yep, that's what you do if you just have a number and x, right? So you have to get used to all this. Right, more examples, guys. Number 6. What happens when you have y equals to a number only? For example, like this, y equals to 5. You just have y equals to 5. What do you do? Right. So if you want to imagine there's an x besides the y, you can imagine it as y equals to 5x to the power of 0, because x to the power of 0 is 1. Therefore, 5 times 1 will be 5, right? And yeah, so when you do dy dx, it becomes 5. 0 you bring in front, 5 times 0, x to the power of 0 minus 1. So dy dx actually is 0, because, you know, 5 and all these times by 0, you're going to get 0. So the logic is, if the equation is y equals to a number, then dy dx will be just 0. So you don't have to show the working. For example, here we have y equals to negative 8, so you can straight away answer dy dx equals to 0. Right. If y equals to 5 over 7, a fancy number, it doesn't matter. Dy dx will still be 0 because there's no x there. Right. Next one. Oh, here we have longer equations, right? But it doesn't matter. You can just differentiate one by one, right? So like if y equals to 3x squared minus 4x, then dy dx will be, right? See, if you show all the working here, then it will be too long. You can straight away do it. 2 you bring in front times to 3, you get 6x to the power of 1 minus 4x. When you differentiate, you get 4. That's all. That's how you answer that. This one, dy dx will be, x squared will be 2x because 2 you bring in front and the power you minus 1. This is minus x. So negative 1x, when you differentiate, you're going to get negative 1. Negative 10, when you differentiate, is going to be 0. Right. So that's the answer. Right. Here, oh, we have y equals to x plus 6 squared. So you have to expand this first, right? So when you expand this, it will be still y. And when you expand this, you're going to get x squared plus 12x plus 36. Now we can do dy dx. So dy dx will be 2x plus 12 because 36 will become 0. That's all. Here you have to expand also, right? So y will be equals to 2x squared plus 14x minus 3x minus 21. Therefore, y equals to 2x squared plus 11x minus 21. So dy dx will be, let me check. Yep. So dy dx will be 4x plus 11. That's it, guys. So easy. Right. I'll see you in the next video.